Given that set P is equal to 1, 2, 2.5, 3, 4, 5, 7, and 9.5, and Q is equal to 1, 2.5, 3, and 7, and R is equal to 5, 4, and 2.5. We have to find P union Q union R and P intersection Q intersection R. Now this is a question from set theory with 3 different subsets. And our responsibility here basically is union and intersection of set. The first question that asks that we should find P union Q union R, that's requesting for the union of the 3 subsets P, Q, and R. While the second one, P intersecting Q intersecting R, is asking for what's common between the 3 subsets that we have there. So anytime you have union of set is to add everything that you see in the 3 subsets without repeating any of the numbers. Because when you look at subset P, there are some elements in subset P that you already have in Q. There are some that you have in subset R. So in finding the union of sets, particularly the union between the 3 subsets here, you are simply going to list all the elements that you can see in set P, set Q, and set R without repeating anyone. So for the first one, our P union Q union R will be equal to, you start listing the element beginning from the smallest to the greatest. So there you have 1. Next to it you have 2. Next you have 2.5. Next you have 3. You have 4. There is no 3.5. After 4 you have 5. There is no 5.5. Next, there is no 6 there too, so the next element there is 7. After 7, there is no 8, so we'll move to 9.5. So by this, you've successfully listed the elements in the 3 subsets together by first going through the element in subset P, that of Q, and R. When you check for set P, for instance, there is 1. We have the 1 here, 2, 2.5, 3, 4, 5, 7, then 9.5. When you come to set Q, there is 1. That one is already represented here. There is 2.5. There is 3, there is 7. So set Q is well represented in this solution. Lastly, when you come to set R, there is 5. That 5 is here. There is 4. You also have the 4 here, and there is 2.5, which is also represented here. So this is P union Q union R. You are not supposed to repeat any element. Otherwise, when you look at the 3 sets there, you have 1 in set P, you have 1 also in set Q. But you see here that it's only one of them that you are seeing. Also, we have 2.5 here. We have 2.5 here. We also have 2.5. There is 4 here. There is 4 here, but you will not see them repeated. That's how to address union of set. Over to the second question, where we are asked to find the intersection between the 3 of them, P intersecting Q intersecting R. In this case, you are simply going to check the elements of the 3 sets and see which of the elements is common to the 3 of them. Which element can you see in set P? That element is also in set Q, and that element is also in set R. So in set P, you have 1, in set Q, you have 1, and in set R, there is no 1. So 1 is not an answer in this case to be, or it's not an element to be listed here. Also, there is 2 in P, there is no 2 in Q, there's no 2 in R. So 2 is not an element to be listed in P intersecting Q intersecting R. Next, we have 2.5 in set P. We also have 2.5 in set Q. And we also have 2.5 in set R. So 2.5 is an element that is common to the 3 sets. And obviously, that's the only element that is common to the 3 sets, because when you see 3 here in set P, you have 3 here in set Q, but there's no 3 in set R. There is 4 in set P, there is 4 in set R, but there's no 4 in set Q. Also, we have 5 in set P, we have 5 in set R, but there's no 5 in set Q. So that is not an element to be listed here. Next, we have 7 in set P, 7 in set Q, but there's no 7 in set R. So we cannot list that element here. And lastly, we have 9.5, which is only present in set P. So that implies that 2.5 is the only element that can be found in P intersecting Q intersecting R. There are other questions that can come out from this. They can ask you for P intersecting R, P intersecting Q, Q intersecting R, as the case may be. In that case, you check between the 2 subsets that they are asking you to find per time, like P intersecting Q. That will be the elements you can see in P and are also in Q. And obviously, all the elements you are seeing in set Q are also here in set P, like 1, 2.5, 3, and 7. So all the elements you are seeing in Q are also in set P. So we can say P intersecting Q is equal to, you have 1, 2.5, 3, then 7. If you are asked to find P intersecting R, P intersecting R will be the elements you are seeing in set P that are also in set R. Also, all the elements you are seeing here in set R are also present in set P, because 5 is here, 5 is also here, 4 is here, 4 is also here, 2.5, 2.5 is also here. So the intersection between P and R, it's equal to 2.5, 4, 5. Also, you can be asked to find the intersection between Q and R. That is, what are those elements that you have in set Q and are also in set R? And the only element here is 2.5. So only 2.5 is common to the 2 sets over there. So this is how to address questions on the intersection of set and the union of set.